The topic for today is quite short, but if you don't know it, you're potentially leaving quite a few marks on the table in the exam. Today we're going to look at writing the limit of a sum as an integral. So in these type of questions, we're going to see a sigma for the sum, and before the sigma, we're going to have a limit, which we usually write as lim. You will have seen that when doing differentiation by first principles. Below the limit, you're going to have to know your Greek alphabet a bit. We're going to have a delta, which you may not have seen before. After the delta, we're going to have an x, and it's going to be tending towards or going towards getting smaller and smaller until it basically gets to 0. In these type of questions, you will have some value below the sigma. So it could be anything here. I'll just put a 1. And then you'll have another value above. So, for example, 3. After the sigma, you're going to have some algebra. It might be in brackets, it might be not. So it could be, for example, 1 over x squared. It could be plus tan x. It could be plus e to the x. Anything really that is possible to integrate is probably going to be in there. And then the final thing to finish this off, this little cap at the end, it's a repetition of the delta x. And it's very much an association game. This looks maybe nothing like anything you've seen before, but what it represents is just an integral. And if you know it represents an integral, even if you don't quite understand it, then all we do is we copy the 1 and the 3. We copy what's inside the algebra or the trigonometry. We copy the x, and the only thing that we don't copy is, rather than doing delta, we do d. As delta x tends towards 0, the delta turns into a d. So the delta Greek letter turns into a letter D in English. So that's what you've got to recognize. That's what's going to get you marks. So that will get you the marks if you have the recognition between the limit of a sum is the same as an integral. That will get you the marks in the exam. But maybe you're more interested in the reasoning. What we're looking at here is some function. It could be any function really. And when we say delta x, what we mean by that is some small change in x. So a very narrow, almost rectangular shape. And what we're trying to do by writing it as a sum is we're trying to say, let's take all those rectangles and add them together. Don't know about you, but if I think about adding all these rectangles together, I do the area of that plus the area of that plus the area of that plus the area of that. Is that not the area underneath the curve? Is that not what an integral can represent? The only caveat then is, why do we put the limit on? And the reason is we don't want some big chunky rectangle like this, because the rectangle out that's made with that delta x specifically doesn't really match up to the curve. So we want some teeny tiny rectangles which are really, really close and hug the curve nicely, such that when you take that limit, when you make them really, really, really small, it will be exactly the same as the area, or in our case, it will be exactly the same as the integral. So even if you don't fully understand that reasoning, you can still answer these questions. It's probably only worth 1 mark, the first part here, but you need it to be able to answer the second part. You need to understand how to get from the limit to the integral before you can start actually evaluating the integral. So when we see a question like this, you see a limit sum, you know it's going to be an integral. So how do you rewrite this limit? We'll put an integral there. The bottom limit's going to be 3 and the top limit's going to be 10. I'm just copying. I'm not pulled those out of nowhere. I'm copying the 3 here and I'm copying the 10 here. Inside the integral, I'm going to put x squared plus 1. Again, I'm not plugging it out of nowhere. I'm just copying and pasting it from here. And what am I going to put on the end? Well, not delta x, but just a standard dx, like we do in every integral that we've seen thus far. That's it for 1 mark. How easy was that? And then if you need to answer part B, hence find the value of it, if you know it's an integral, then all you need to do is find the value of this integral. So I won't go through it properly, but you'll do the usual funky stuff. Sub in 10, sub in 3, subtract, you get some answer, and you get an extra however many marks. So an exercise for you should be a quick one. Can you rewrite this limit of this sum of x e to the x squared delta x as an integral for me? And that is all you need to know. It's just a recognition game or a memory game of seeing that limit of a sum and knowing, not necessarily understanding, but knowing that it's the same as an integral. That should get you 1 mark for rewriting it, and hopefully a few more for actually evaluating the integral. Well, there you have it. That's how to find an integral as the limit of a sum. Wasn't too bad, was it?